Hey, good morning, everybody. It is a beautiful, surprisingly, Saturday morning. My backdrop is not where I am. This is a little bit different today. We are doing a really interesting and timely and topical Science Saturday. So, you guys may have noticed it's September, and in the Caribbean and in the southern United States, we know what September means. This is the height of hurricane season, which I know gets us all a little, but if you want to if you're afraid of something, if something makes you anxious, a really, really fantastic way to deal with that is to learn about it. And I've said this probably not on Science Saturday, but if you're afraid of something, learn about it. And then you can have a healthy fear. So, as you can see on my screen, we are talking about hurricanes, and we have a really fantastic special guest with us today. First, I know you can all see Joe. Hey, Joe. I know we said that it was Joe's last Science Saturday a few months ago, but he missed us so much that he is hopping on for some technical assistance and to keep me on track. And so we are so happy to have him, but our super amazing, fantastic special guest today, drumroll, we have Nancy from the National Weather Service based out of the Florida Keys, a meteorologist. And this is a type of science that I know nothing about. And so this is really, really, really exciting. And so Nancy is joining us from the Keys. And so this is our first ever Science Saturday with, I hope I'm saying this right, but I'm pretty sure this is our first ever Science Saturday with an out of territory guest. So welcome, Nancy. Hey, how's it going?
Good morning. Good. How are you?
I am fantastic.
All right. Well, I guess we'll get started here. So welcome to Science Saturday, and we will be talking about hurricanes today, which, as she said, is very timely with Lee lurking around. But we'll kind of talk a little bit about Lee and any type of impacts to the U.S. Virgin Islands, which is very minimal, luckily. So first of all, I wanted to start talking about the National Weather Service, just because that's the organization that I'm a part of. And we actually have 122 forecast offices across the nation. And even in territories such as Guam. And for you guys, your office is actually going to be Puerto Rico. So I don't know if you can see my mouse clicker,
Yeah.
but it is all the way down here. So that is your office, and that is actually who takes care of your weather. So going into head, what does the National Weather Service do? Why are we here? So what we do, this is just specific to the Florida Keys, but this is what all of us do. So we're the ones that are going to be issuing the forecasts and the warnings for the Florida Keys. So San Juan will do it for the Puerto Rico and the adjacent coastal waters and adjacent areas such as the Virgin Islands. Specifically during hurricane season, what we do, especially if there's a system about to impact the Keys or whatnot, we actually coordinate directly with the National Hurricane Center, which they are the experts of experts on tropical when the tropical cyclones do threaten our area. So our staff at our offices, at each office, is composed of a majority meteorologists, and we also do have electronics technicians and IT specialists to make sure that our radios work and our radars work, which is very, very important to our operations. So moving on, now we're going to get into the tropical cyclone portion of it. So what is a tropical cyclone or a hurricane? As you can see from my map that I have up here, we call them hurricanes here, but in other locations, you're actually going to hear them called something else. So if you're in the southern hemisphere, you might hear them referred to as cyclones, or if you're near Asia, you might hear them referred to as typhoons or super typhoons. But here we call them hurricanes.
So that's all the exact same thing. There's no difference in how the weather behaves. It's just what it's called.
Yeah. They're just different names. Yeah.
Okay.
So they form the exact same, same area, same everything, but they're just called something different. But so for what is a tropical cyclone? So it's actually a low pressure. So there's some type of pre-existing weather disturbance that originates over tropical waters. So you can see all of like the arrows, they all begin somewhat close to the equator, not quite at the equator because they still need some of the large scale turning effect called Coriolis. So you can't be right at the equator because you don't have that. But you have to start off with the organized like thunderstorms. You can't just hurricane starts. So you have to actually have that pre-existing weather condition. And then you also have to have a closed surface wind circulation about a well-defined center. So that is what most people refer to as the eye. But something that's interesting, especially in the lower end hurricanes, sometimes you can't see an eye. So what we'll do is, you can send hurricane hunter aircrafts in there for reconnaissance. You can look at satellite-derived winds, if like a scatterometer, which basically it can look at the wave heights and determine the winds. So we can actually see where the circulation is. And that's a lot of times how the National Hurricane Center will actually determine. They can see how high the winds are, and if there is a closed surface wind circulation, that's when they're like, all right, we're gonna name it. For the Atlantic hurricane season, that is going to be June 1st through November 30th. But, however, things can form outside of that. I've seen it once or twice, very rarely, but they can.
So I feel like we're starting to see storms creep into December, even.
Yeah,
and
we've
so
definitely seen that.
You were talking about it, but just kind of to wrap my head around it, you start with the thunderstorm. The real difference between a storm and a tropical cyclone is the spin or the pressure or both. It's kind of all of it.
It's kind of like the whole thing. So that's kind of what I'm going to get into now.
Cool.
So the pre-existing weather disturbance. So you can have a cluster of thunderstorms. However, a lot of times what we'll see, especially with the ones coming off Africa, are going to be a tropical wave. So tropical waves are kind of the elongated areas of the cyclonic. So cyclonic, when I say that, that's going to be counterclockwise. So go backwards around the clock. And that's generally what we see when we have kind of disturbed areas or unsettled weather. We see low pressure as opposed to high pressure, which is going to be the clockwise rotation. But tropical waves, actually, a lot of times, which has happened with, Margot and Lee, and they're all African easterly waves. So they're these tropical waves that are moving off Africa, and they move into the Atlantic. They don't have to exactly all come off of Africa. They can develop, but a lot of times that's what we see, especially during this time of year. So this is just a pre-existing weather disturbance that is the elongated area of low pressure. So instead of having, that deep, that actually like the eye around the defined center, they don't actually have an eye, but they are still elongated.
Right.
And
so
having that still cyclonic
the
curvature.
picture on the screen is, I noticed that it doesn't have great circular, although I think we can find the Virgin Islands in here if we do spot the VI in here. Well, obviously you can't see my finger, but I'm definitely right.
Right around here.
Yeah, and so this is just a weather cluster moving through?
Yeah, it's a little bit harder to see. If I wish I had gotten an actual video, because what you can see is you can actually see when you're looking at a tropical wave, because we have them actually move across all the time, and they don't always form into hurricanes just because they might not have the right conditions or the right setup, or it just doesn't happen. But you can actually see the cyclonic flow in the clouds. It's very interesting. So if you're interested, you can probably look it up on Google and just see how you can see the cyclonic flow or the counterclockwise flow within the clouds. So so I try to pick one over, but a lot of times they'll just bring rain and not necessarily. So if you hear a tropical wave's moving off of blah blah blah, it's not always going to turn into something. Sometimes it does, sometimes it doesn't.
Right.
But
it's just one of the ingredients. Actually, the NOAA communication newsletter that came out this week, they do communication product of the month, and there was the makings of a taco and a taco, and so this is one of the ingredients, but it doesn't mean we're gonna have taco night.
Exactly. Yep.
Maybe
So
just some shredded
that
cheese.
is very. Yeah. So it's like the meat.
Yeah.
Um, so then your lettuce. So you need warm water. So this is another thing. This is why we only generally see tropical during the June 1st through November 30th, because that's when you're going to see the warmer waters, and that's what they thrive off of. So this picture, this is from yesterday actually, which is, it's kind of interesting. I want to show you something in just a second. So just with my cursor, but this is generally, you're going to see this path right here is where they're going to follow, or out to sea, or wherever. So you can see that the water temperatures are very, very, very warm. So they're at least 30 degrees Celsius, which is definitely what is needed. And I just want to point out another feature. I hope you all can see it. I get my mouse. So right here, you've got the Gulf Stream. So that's the warmer waters. But interestingly enough, right here, you see that there's like a big path of slightly cooler waters. And you're probably like, what? Why? Well, something interesting is that this is actually the wake of the tropical cyclone or Hurricane Franklin. Because when you have a stronger storm like Franklin was, I can't remember exactly how strong Franklin got. What it does is it creates a lot of waves and a lot of swell, and it upwells. So it brings up that cooler water from down below, and it brings it more to the surface. So you might actually see, like, we can actually see on satellite where Franklin traveled, which is pretty cool to me, because, you know, Lee might go through there and be like, oh, this is a little bit chillier. I might want to decrease my strength or something like that.
We have a
just because
question
he
from
doesn't have
Joe.
that strong, or that very, very warm water. So just a fun little thing to point out here that I was looking at this morning when I saw. So
Yeah. What's up, Joe?
all right.
Sorry, I promise that I will not insert the choral work too much, but this is just, it's so intertwined, right? So the reason is this is a really crazy picture of how warm it is right now, because this is the 8th. This was yesterday, right? And so we in coral science, we're talking a lot about how warm the water is and how that's causing a problem for our reefs. And one of the things we talk about is if a storm comes through, it allows this mixing that creates cooler water that can actually rescue corals from thermal bleaching. So cool little miniature connection. And then I had a question, so I'm gonna take the chance to ask. So you mentioned how storms generally follow that path. We see, like, we're always watching off the coast of Africa,
Yep.
Cabo Verde Islands, and then up. But there's also, I mean, in those same reports from the National Weather Service, the National Hurricane Center, storms that'll form like in the Southern Caribbean,
Right.
and in the Gulf, and those are much smaller areas. I mean, you talk about like a pretty long track line to get from the
Right.
to us. So
Yep.
do they just not need as much water? Like, how are those areas still able to produce these powerful storms, even though it's a lot smaller of an area? Does that make sense?
Yeah, so they also it'll still develop off of something such as, say, the Central American Gyre, which is just like another area of low pressure. And it takes all that extremely, because you can see in this picture how extremely warm the water is in the Gulf. And this is actually where the most previous one, Adalia, formed. She actually formed in the Gulf, or in the Caribbean. So some storms, they don't need exactly the entire length of the Atlantic Ocean. Some of them take it, some of them don't, but we do see a decent amount of storms, and it's interesting. I'm going to show a picture later of kind of like the September climatology of where storms form. But the later you get into the season, it's actually going to be more dominant from the Western Caribbean and the Gulf, just because the waters are starting to cool between Africa and the United States, and you still have these very, very, very warm waters that are just bubbling in the Gulf, and so you still have most of the ingredients, or almost all of the ingredients, for storms to form in the Gulf and in the Western Caribbean. So yeah, we definitely see a lot, and that is a little bit more stressful because these storms do form. Like, global models, they can pick up on stuff, but they do form. And then for the National Weather Service purposes, once we're in like the cone, as they call it, we are like going hard. Like, we have 12-hour shifts, and having a storm that forms in like the Western Caribbean, it's like, oh, okay, we're going. But one that we can watch, like Lee, and I feel like we've been watching Lee for 2 weeks now.
Yes, we've been watching Lee very closely.
It's
For those
just-
of us
it's
a
like
little bit further east of Florida, I feel like
Yeah.
we're the testers for you guys.
Yes, you are. Yes, you are. You see what's going on. But so yeah, but no, there a lot definitely do form in the Western Caribbean and in the Gulf. So I hope that kind of answers your question.
Yeah,
Ish.
that's really interesting.
Okay.
And seeing how they, and in your earlier map of the different like areas with hurricanes and typhoons, I think it's interesting that they're all coming from different origin points around the globe and going in the same direction. Which, why do they all go the same way? Except for sometimes they like do. I remember one year there was Lefty Lenny. He like came up and then like went down and spiraled, and so you can never stop watching
there
them.
can be
but-
some very crazy hurricane or tropical storm tracks just because of that's more based on kind of the steering mechanisms. Like you might have what we call like the Bermuda High, and so that goes clockwise and it steers it this way, and all these different things like steering mechanisms. Like luckily right now we have more of like across the East Coast, we have more of like a counterclockwise, so an area of low pressure, which is why if anyone watches weather, it's okay if you don't, why they're having more like unsettled weather up on the East Coast, like, and so just because of that low pressure. But luckily, with that low pressure, that's actually what is steering Lee away from us. It's helping that northward turn. So there's a lot that goes into. There's a lot of things that could change and whatnot. Not with Lee specifically, but just like, this could be steered this way because of this reason. So it's very, very specific to each and every single storm. So if you see someone showing a track of, oh, well, this storm did this, and it's very similar to this storm, well, that doesn't mean that's going to exactly happen because it's a whole different environment. Because each storm one of my managers says, which I find it's very, very true, that each storm is like a snowflake. None of them are the same. So you have to look at it with a new eyes every single time like another storm comes.
Right.
So
Yeah,
Yeah.
I know we get kind of used to looking at the other storms, and if one is coming up behind them or like over and pushing it down, like it's crazy to think that all of those weather patterns, not just in the Caribbean, not just in the Atlantic, but a cold front, coming down, Canada could affect the storm.
Yep.
It's wild.
Exactly. Yeah, it's something interesting. During Hurricane Ian last year, there was something that was going to potentially affect it, like the storm, like the steering motion of the storm that was coming out of the Pacific Northwest. So what we do, we actually launch weather balloons during tropical operations. If requested by the National Hurricane Center, we'll launch them 4 times a day as opposed to the regular 2 times a day. So something that I thought was very interesting and how all weather is basically all interconnected is they were having offices in the Pacific Northwest, such as, Portland, Oregon, and those Seattle and those type of areas, doing launches 4 times a day in support of tropical operations. Because even though they're so far removed, that one weather feature was going to show us, exactly where it was going to be steered. And they really wanted to go up and sample at least 4 times a day just to get a better grasp on what this is going to do, because it made such a big impact on where Ian was going to go.
Wild. Very
yeah,
cool.
I know. Oh, okay.
All right, we totally derailed your presentation, but onward.
Yes, so, all right. So another ingredient, so I guess the cheese. So it's something that you need. It's going to be moisture. You really need deep tropical moisture. So if you have a really dry day, or I'm sure you've heard of like the Saharan air layer that moves off of Africa, dust, and you can see it, and like it's murky or milky skies. That's not going to be very conducive to having a hurricane that relies on this moisture for its energy. So you can see this might be a little bit harder of an image, but I'll show you right here where my cursor is. This is actually Hurricane Boba over in the Eastern Pacific. So you can see the moisture looking at the scale. That's 3 inches, which is very, very high. And this is just like the atmospheric moisture content. And then going over here, you can see Lee, which also has very high atmospheric moisture. this moisture basically just feeds the storm, and if the moisture source is cut off, then the storm will definitely weaken.
Interesting.
And then going into the last thing is they need low wind shear. So, let's see, what is wind shear? So there are two different types of wind shear. So in this first picture right here, we have, no low wind shear, everything's going good. So it can actually be, the storm can be vertically stacked, kind of how you see the eye. That is a vertically stacked storm with no wind shear, with little wind shear. But then you can get speed wind shear, which is an increase in speed as you go up through the atmosphere, which we definitely see a lot, which is actually impacting Hurricane Lee right now, which is why it decreased in intensity. But so if you don't have this great, nice, straight up, no vertical or no speed wind shear, it can actually weaken the storm. And then same goes with directional wind shear. So directional wind shear is just a differing of direction as the winds go up. So you don't have this nice stacked vertically perfect hurricane anymore. It kind of shears off into a mess and weakens it, depending on how strong the shear is. So you just want low wind shear, moisture, a pre-existing tropical disturbance, and very warm waters. So those are the 4 key ingredients. So now, interestingly enough, I'm looking at the tropical cyclone activity by date, and we are 1 day off of the actual peak of tropical season, as defined by NOAA. And which is interesting for the Florida Keys here. We have had 2 strong storms happen exactly on September 10th. I know in 1960 we had Hurricane Donna, and then in 2017 we had a Hurricane Irma right on September 10th. So I'm like, okay, I believe September 10th is definitely the peak.
and so we're just slightly before you guys.
Yeah, exactly. So
although
Hugo
was later in September, but
yeah. So
we can concur.
But this is when you see the climatological peak, because all of the factors are in sync, especially the warmer waters. Because as of now, we're seeing not as high of a sun angle, and the waters will start to cool this year. Maybe not as rapidly, but we'll see. So something that you were talking about earlier, Joe, is the zones of origin. So this is the September zones of origin, and this is basically, they'll form anywhere they want, just because everywhere is basically conducive. And so you can see there are 2 different tracks. You've got the long track from that starts at the Cabo Verde Islands and that makes it all the way, like Lee and Margot and Franklin and all of them have done. And then you've got the Idalia or Idalia tracks right here out of the Western Caribbean. So you can basically see a hurricane from any of these. Earlier in the season, you might see more from the long track ones, but like you can basically get them from anywhere because of how warm the waters are right now. That's not saying that all the ingredients are going to line up and we're just going to have a plethora of storms, but you can basically get them from anywhere. Okay, so I'm actually going to go to YouTube, so bear with me for a second, and I'm going to show you. Hopefully you're going to be able to see this. All right. Okay. All right. I'm going to play this for you. How hurricanes form. So it's just a 2-minute short video.
Where did these Chinese? Ooh. So we're not getting sound, but we have subtitles, so it's okay.
Okay, so do you want me to?
No, you can keep going. I think it's just the Google Meet.
Okay.
Yeah,
I'll read it for you guys
Okay.
in a theatrical voice. At least 80
Mary.
degrees Fahrenheit. Oh no, it's going too fast. Wind is also needed for a hurricane to form. Many hurricanes in the United States are caused by winds blowing across Atlantic Ocean from Africa. I skipped a line. This wind causes even more of the warm water to evaporate into the air. The warm, moist air then rises into the atmosphere where it begins to cool. Way up there, the water vapor condenses back into liquid water droplets. Water droplets in the atmosphere form clouds, including big, stormy cumulonimbus clouds. Oh my goodness. As the warm air continues rising upwards, circular patterns around the center. Oh guys, I am destroying this. I apologize. I hope you're reading this, and you can go back and rewind the video earlier. But while this is going, we have done Science Saturdays on the water cycle that Joe did some experiments with, so we can review those later as well.
These are a little bit bigger examples of the water cycle than what we talked about.
Yeah. Weather satellites that are constantly monitoring the conditions down on Earth. The GOES-R series. Aw, look at them with the camera. Taking pictures of what's going on, keeping an eye on things. The categories, yep, so we know that the categories start with 1 and go up to 5. We've had a few category 5s down here. Lee, I believe, is a category 5 right now. Or just was.
Thank you for narrating that. Sorry about the noise.
No, I rocked it.
So that was just a brief overview on how they form. So now we'll kind of go into the different types of tropical cyclones or hurricanes. So there are 3 different types. You have a tropical depression, which is a tropical cyclone that has a sustained surface wind speed of 38 miles per hour or less. Then you have a tropical storm. This is where they're going to name it. So tropical depression does not have a name. It may be like tropical depression 13 or tropical depression 10, but they don't have a name yet. So tropical storms are when the name is given, and that is where the sustained surface wind speeds range from 39 to 73 miles per hour, which is a very big range. We have learned that very strong tropical storms versus very weak tropical storms produce very, very different damage. So if you hear a tropical storm's moving through, don't take it too lightly. I know it's not a hurricane or whatnot, but 73 sustained up to 73 miles per hour, it's actually very strong and can produce a lot of damage. And lastly, a hurricane, which is a maximum sustained surface wind of 74 miles per hour or more. So those are just the different delineations between those. So these are the tropical cyclones that we have named so far. So we have gone all the way through K, and right now out there we have Lee and Margot. So we still have about half of the list to go. So we're doing well. All right, so now that we've talked about the difference between depression, storm, and hurricane, we can dive a little bit deeper into the Saffir-Simpson between category 1 through 5. So of course, 1 is going to be 74 to 95. So it's still very, very dangerous, even though it's only category 1. No, you still need to prepare for those. And category 2 is going to be 96 through 110 miles per hour. And once you get to category 3, this is where they start terming them major hurricanes, just because devastating damage is very, very possible. So that's going to be between 111 and 129. Once you get into the Cat 4 or 5 range, catastrophic damage is very likely. It will occur because a Cat 4 is 130 to 156 miles per hour, and then Cat 5, you don't want to be there during Cat 5, so that's 157 miles per hour or higher. Yeah, you don't want to be
and these are sustained winds.
These are sustained.
Yeah.
This does not include gusts.
Yeah, take it away, Joe.
Yeah, I mean, Kitty, you said one of the things. Yeah, sustained wind, which is crazy. But the other thing I was thinking about too is I think a lot of people look at this and they see, like you said, category 1, and they kind of relax a little bit. But here in Puerto Rico, like there were several storms that were low category storms that caused major damage because this doesn't account for the precipitation or the size of the storm. So
or
actually,
the storm surge.
Or the storm surge, right? And so the last year was Hurricane Fiona, as it came through, was not a major hurricane at the time, but caused extensive damage where I am in La Paquera and in the south and west of Puerto Rico, and they, because of the rain, because of those impacts, and can cause major difference. Yes, I agree. It can cause a problem. Anyway, that's all we had to share over here in Puerto Rico.
Yeah, it's something that a lot of people don't take into account, because I think in Fiona, I can't remember if I'm remembering this quite correctly. I think there are some portions of Puerto Rico that got like 20 inches or more of rainfall. That might have been the same thing.
Right.
And it caused like massive like mudslides and all that stuff. So
Yeah.
yes, the categories do not take into account all of the impacts. They're just focusing on the winds. And so, as I mentioned earlier, no storm is going to be alike. So you can have a category 1 that, you know, it doesn't produce as much rainfall as another one, but that could be because, you know, you might have a slower moving storm and it might just dump rain on you for hours and hours and hours. Or, you know, you might have the storm surge, like Kitty mentioned, or there might actually be a tornado that comes to your town. So you can't just focus solely on, you still have to prepare well for 1 through 5, or even a tropical storm, because for Hurricane Ian, we were actually under a tropical storm warning, and we had storm surge, we had rain, we actually had a tornado move through our area. So they bring a multitude of hazards. So it's hard to not focus on the wind because that's what everyone talks about. But just know that there are very many other hazards that come along with hurricanes besides the wind, even though the wind is extremely dangerous.
Yeah.
Okay, so now we're going to go into the tropical storm watch versus warning. These are just the definitions of them. So if you ever find yourself in a watch, whether it be tropical storm or hurricane, that just means that specific type of conditions are possible within the next 48 hours. Then for warnings, that means that those types of conditions are expected within the next 36 hours. So sometimes, rarely, they'll actually keep, like for Dahlia, we were only kept in a tropical storm watch because it was possible that we might see it in the next 48 hours, but we never actually reached it, so it was never upgraded, and it wasn't as certain. But generally what they'll do is they'll put out a watch, and then it will be followed by a warning. So it's just more of like a timeline kind of thing. So something I also want to talk to you about is what I've been talking about, like prepare. Always, like, it doesn't matter if NOAA said, oh, it's going to be a below normal hurricane season. That doesn't mean you should say, oh, let your guard down. I'm going to not prepare this year. Always make sure you have a hurricane kit, a hurricane plan, just because you never know. It only takes one, is what we always say. So this is what a below normal season looks like. There was maybe 8 storms. I'm not exactly sure. It looks like roughly about 8 storms. And this was in 1992. And what happened this year, there was one bad storm that hit South Florida, and that was Hurricane Andrew. And for those of you that don't know, Hurricane Andrew was a very small storm, very compact. It was very devastating to that area. So the people in South Florida are like, oh my gosh, that was the worst hurricane season ever. But say the people in North Florida, like, nothing happened. It was below normal. But so it only takes one. And I'm not saying it's always going to hit your area, but it's very good to prepare for that. And an interesting fact about Hurricane Andrew, is so intense that after Hurricane Andrew, I guess architects or house builders, they actually raised the code of building houses to meet Hurricane Andrew effects. So that's just something that's fascinating to me, because one storm made all of the different code and how you build a house, especially in Florida, very different. But once again, just don't let your guard down, and always have your hurricane plan and hurricane kit ready every June 1st.
Yep.
So something that is good is that we have seen improvements in track forecasting. Is there a question?
Oh yeah, Andrew. That means that it was early in the season.
Yes, it was actually in August. August, I can't remember the exact date of it, but it was August. So yeah, you don't have to wait till September or October to get the peak. It can happen whenever, especially when the conditions are right. And you can see that it went from not much happening. It's something that we have been seeing more often is rapid intensification, but this actually looks like it rapidly intensified, because it wasn't really anything here, which the blue is probably like a tropical storm. I'm not exactly sure what it is, but then once it gets here, red is category 5.
Right.
So just don't say, oh, the other day I looked, there was only a tropical storm. No, you got to keep it. So always keep your guard up. So as I was mentioning, luckily since 1990, right around when Hurricane Andrew did happen, we have seen major improvements in track forecasting from the National Hurricane Center. So this image is showing the 3-day forecast accuracy from 1990 versus 2021. So roughly 30 years. And so 30 years ago, you could have had the center, just the center, not all the impacts and whatnot, go through West Palm Beach or go south of Cuba. Now, for Florida Keys, this is how we talk about it. It can either hit Key West or Key Largo. So Key West is right down here, and then Key Largo is up here. So that is a very, very big difference, and it's very, very exciting to see how much better the track forecasting is getting. Are they going to be right every single time? No, there's going to be instances where, you know, they have to change their forecast. But in general, their forecasting accuracy has improved greatly, which is very exciting for everyone involved.
Yeah, that's very cool.
Yeah,
and that's analyzing all the ingredients we were talking about earlier, where you've got, you know, the weather balloons going up in Seattle, and, you know, some dry air coming across Africa, and it's crazy.
Yeah.
It's so much.
Yep. So this is something that I'm very excited about, and I know it'll just probably continue to get better. So as you know, global models or the things that and people that predict hurricanes, they're just it's awesome. So very positive thing to look at. Okay, so something I did want to talk to you about is Hurricane Hunter aircraft. So I mentioned them earlier as how you can actually see what the storm looks like in terms of wind speed and pressure. Here are just a few of the NOAA Hurricane Hunter aircraft. So you up in the upper left-hand corner, you've got a P3, so that's one of their bigger planes. This is the G4, or the Gulfstream 4
That guy
they
goes
use,
into
and
a
this all
hurricane?
has very. Say that one more time?
That little guy goes into a hurricane?
Yeah, I don't know exactly if they go all in the same location,
Right.
so I've never
Fair.
actually asked that.
Yeah.
But they all have very specific instrumentation on board, and they actually have the pilots as well as meteorologists. And they're centered out of Lakeland, Florida. And so, so some of them actually have like a tail radar, so they can actually see a radar of the storm. So it's pretty neat. It's kind of crazy to think that they are flying into a hurricane.
They stop here in the Virgin Islands.
Exactly.
And so the guy on the, I don't know why I'm personifying these planes. They have a rough life and an important job. So the one in the top left, one like that, I think is on St. Croix right now.
Yes, they actually are. I was going to talk about that. So the last one is going to be the Air Force. The Air Force also does help. So if you hear anything about Air Force hurricane hunters, they actually work in unison, with the National Hurricane Center. So as you were talking about, a lot of times the hurricane hunters will fly out of St. Croix. So they're actually going to be doing missions tomorrow and the next day. They might actually already be there right now. So I know at least the P3, the two NOAA P3. So these big ones right here, they're actually in St. Croix right now, and they're doing missions into Lee. But I know I've seen them going in and out of St. Croix a bunch of times. So St. Croix seems to be a very good location, and that's just somewhere that's closer to the storms rather than taking off out of Florida. They go to various places depending on where the storm is, but right now they're actually in St. Croix. So fun fact.
Very cool.
So I know we've honed in on this a lot, especially in an area that is very vulnerable, like the Virgin Islands or like the Florida Keys for me. Am I at risk? The answer is going to be yes. Because if you are on the coast, which is going to have any type of impact from storm surge, or you're just in a very vulnerable position. So in the Caribbean and in the Gulf for us. So if you say, am I at risk? And the answer is yes, make sure you're prepared during June 1st through November 30th. We can't say that enough, just because we want people to be aware that these things do happen, and just always don't panic and freak out if something is coming to you. So that's just something we try to hone in during the time of November 30th to June 1st, and as well as June 1st to November 30th. We just try and talk about it all year long. Just be prepared, be prepared. So these are just some of the, how we were talking earlier about how wind is not the only threat. So these are just specific to the Florida Keys, just because this is what I luckily haven't seen any of these. This is just damage from storm surge. So, you can have roads washed out, which is what happened in this instant. You can have water spouts. This is a large water spout back in 2005 from Hurricane Wilma. Luckily, it stayed offshore the whole time, but that was a nasty one. And then you can also have the flooding rain. And as Joe mentioned, yeah, you can. Luckily for our area, we don't have that much topography, so we don't have any type of risk from mudslides or landslides. But there are a lot of locations that do. So just something to be wary of, and not just look, because I know that Hurricane Center puts out major impacts, and it's going to be, a lot of times they won't even mention wind first. Like for Adalia, the first thing they mentioned was storm surge, because that was going to be one of the major impacts. So it's just something to watch. So now I'm going to talk, my last topic will be touching on a little bit of climate change and how the hazards from hurricanes will change in the coming years. So this is from NOAA. I am not personally a climate scientist, because climate, I do more of the short term, while climate scientists do more of the long term. So this is just taking this directly from NOAA and the scientists there. So these are some of their projections. Interestingly enough, they think rainfall rates will increase due to the warmer atmosphere being able to, because warmer atmospheres can actually hold more rain or hold more moisture. So higher rainfall rates are possible. The intensities, just due to the warmer waters and whatnot, are projected to increase, as well as a chance of rapid intensification.
That's really interesting. I actually hadn't heard anyone talk about that, and I'm definitely noticing it. Just in my lifetime watching storms in the Virgin Islands, it seems like we're going from, tropical disturbance to major hurricane much faster.
It feels like it. It definitely does. I know there's been at least, I can't remember if Franklin did, but I know Lee did, and Idalia did. I'm pretty sure that Lee did, or Franklin did, but that's at least 3 this year. However, something that's interesting is that frequency, there's no really strong correlation. There might actually predict a decrease, but maybe just with stronger storms. But all of this put together, that does not mean that there's going to be more landfalls. That was not something that we can see within climate change, because as we talked about earlier, that's more of like a shorter term scale thing, like looking at it like how the storm is going to move. That's, you can't predict that. So regardless of how intense they are or how frequent there's rapid intensification, there's no strong evidence linked to more landfalls.
Right, because it's not like it's a magnet like coming towards us. The
Exactly.
hurricanes don't
So
care that
you
we're
might
here.
Yeah,
hurricane's
exactly.
going to do what the weather is doing. We're just in the way.
Exactly. Not what the climate's doing, because you can't really predict that.
Yeah.
And so I wanted to show you one last example from Key West. So talking a little bit about sea level rise. So this is for Key West. I actually looked at the Virgin Islands, and I couldn't find any of like the water, the gauges, the tide gauges that would give me a sea level trend like this. So I just kept it at Key West. So sorry.
It's okay. We're often ignored in data tools, but
Yes. So you can see. So with this black line is the observed. So not every year it goes up. It's definitely it doesn't go up every single year, but the overall linear trend is upwards. And so what these are right here is possibilities of where this is going to go, where this little observed line is going to go.
Right.
And I'm not personally saying it's going to go to any one of these, but it just really depends on what happens in the coming years, whether it just keeps following its linear trend like this, or if it becomes more exponential. So this is like worst case scenario here, and this is best case scenario. But we just still see and expect like increase in sea level rise.
right.
And this will also affect the Virgin Islands, even though you do have a little bit higher elevation than Key West, with some mountains and whatnot, but it will still impact you guys. So I just want to, this is my example. So since we have been seeing like higher sea level rise, the example I'm about to show you might actually happen more often. Not the exact one, but so for Hurricane Ian for us, Key West actually ended up seeing a decent amount of storm surge. So this is not a storm surge map. What it is we had I guess it was like a sensor that
Ooh, we
sampled
have.
4 point.
I am so sorry, but my Google Meet is going to cancel in 1 minute.
Oh no!
Oh,
Oh goodness!
here, I thought we
Okay.
had so much time.
Okay, so I can skip this one because I wanted to make sure you see. This is what I want to show you. The last one I wanted to show you. So with with Lee. I took this yesterday. These are probably going to be the main impacts for you guys from Lee. Is you're just going to see, you can see like the direction of, this is wave height. So you're
Okay.
just going to see some swells. So I thought that was interesting to kind of show, since that's your area. So the next thing you're going to see is just an increase in wave heights and some rough surf.
Okay.
But-
So we're going to stay
And
off
then-
the coastlines.
Yeah. So, and then this is the last thing for all of you. Make sure that you're following San Juan on Instagram, or not Instagram, Twitter and Facebook, and then use weather.gov/San Juan, because they are your office and they do take care of your weather. So
Awesome. All right. Well, I don't know when Google is going to kick us off, but I'm going to take the last few seconds, minutes, whatever we have to say. Thank you so much. We are about to get kicked off, but this has been really amazing. Nancy, thank you so much. I know this has been a goal of mine and Joe's. He's totally nerding out over all of this. So everyone, thank you so much for tuning in. It has been phenomenal, and have an excellent Science Saturday.